Hi students. I told you every day I'll post one video. So this is the second day of our organic chemistry. So here I have come up with Markovnikov's rule, another topic from the organic chemistry, which is only for your board exams. Okay. So here Markovnikov's rule. What is Markovnikov's rule? So here here first we'll discuss addition of hydrogen halides. Addition of hydrogen halides to hydrogen halides means HF, HCl, HBr, HI. These are called as hydrogen halides. Okay. Addition of hydrogen halides to alkenes. So here I am taking an alkene. Alkene means double bonded compound, and here I have taken a simple alkene. So here to satisfy the valency of carbon I am placing hydrogen. This is two carbon atoms, eth and double bond ethene. Okay. So simply I have taken ethene, and here addition of HBr to this ethene. So how you will add HBr to this ethylene? So here if you first you observe this alkene. One alkene means here double bond, one sigma bond, one pi bond. So here do not disturb sigma bond, because here pi electrons are more labile. You can easily shift, you can easily move this electron cloud, pi electron cloud, because pi electrons are more labile and the sigma bond is stronger when compared to the pi bond. So here to shift the pi electrons or the pi electron cloud, less amount of energy is required. So here what is your observation? If HBr is added to this alkene, so here this you assume this is the pi bond. So here first I want to tell you some heterolytic and homolytic cleavages. So here just leave pi bond. Here I am shifting these pi electrons to this carbon atom. Here I am numbering. So shifting of this pi electron cloud completely to this carbon atom. This pi bond is belong to these two carbon atoms now. Okay. These two carbon atoms here, leaving this carbon atom, this pi electron cloud, I have completely shifted to this one. So here this carbon, second carbon, is rich in electron because it has gained its so completely the pi electrons are shifted to this one. So it will get a negative charge. Okay. Now here what about this carbon atom? Negative charge means 2 electrons. Pi electrons, one bond means 2 electrons. Sigma bond, pi bond, 2 electrons. Sigma bond, 2 electrons. So here heterolytic cleavage, I told you, no? Hetero means different. Means here if you are completely shifting pi electron cloud to this carbon atom, one carbon is becoming deficient and another carbon is completely accepting that electron differently. So electron pair is differently shared between the atoms, shifted between the atoms. That lytic, hetero means different, lytic, heterolytic cleavage. This type of cleavage we call as heterolytic cleavage. Hetero means different, lytic means breakage, lytic means cleavage. So here this carbon will get a negative charge. Now what I want to tell you is, here this carbon will get a negative charge. As it is, I am writing your sigma bond. I am not disturbing that carbon and 2 hydrogens. And here this carbon lost one bond. Around this carbon atom, if you observe, 2 plus 1, 3 bonds are there. This carbon has become deficient. So this positive charge. Okay. Okay. Now HBr means H plus Br minus. Okay. And now here you add this plus H plus to negative side, negative part of the carbon, and here negative sign to the positive part of the carbon. Then tell me what is your product. So here it is CH2 plus Br minus. CH2 plus and minus will form a bond. So directly I am writing CH2Br and CH2 minus H plus. So this will become your CH3. Here, clear this one. Here, this is the simple mechanism, shifting of pi electrons. This part is called as the head part. Head part carbon will get a negative charge. This is called as the tail part. Tail part carbon will get a positive charge. Simple. So here positive charge attached to the negative side attached to the positive side. So here addition of HCl or HBr or HI to the alkene. If you observe this alkene, so here this is your ethyl bromide. Okay. Now this is the first case. Or ma'am, you can ask me why you have shifted these pi electrons to this carbon atom, ma'am. I will shift the pi electron cloud to this first carbon. Okay. That is the second case. You shift that pi electron cloud to this first carbon. Then we'll see what will happen. Okay. Here I'll clear this one. This is ethyl bromide or 1-bromoethane. Ethyl bromide. Name of this one, ethyl bromide, common name. 1-bromoethane is the IUPAC name. Okay. Now, the second case, just to clear your confusion. Okay. Here I am shifting this pi electron cloud to this carbon atom. Now what will happen? Head part carbon, if the arrow mark is showing this carbon is getting negative charge, sigma bond as it is, and this carbon will become deficient plus charge, and it is your CH2 and it is your CH2 plus and minus. Okay. Now H plus Br minus. Now you attach this plus to minus and minus to plus. Now what will be the product? So here CH2 minus H plus. This will be CH3 and CH2 plus Br minus. This will be CH2Br. So what is the name of this one? This is also ethyl bromide or 1-bromoethane. No. Why? Because it is a symmetrical alkene. It is a symmetrical alkene. What is meant by symmetry, ma'am? Here, if you observe this double bonded carbon atoms, carbon, double bond, carbon. Okay. Here, what are the atoms attached? Here, hydrogens. What are the atoms attached here? Hydrogens. So both are having same chemical environment. Both carbons are same. So if for this type of alkene we call as a symmetrical alkene. So if you shift pi electrons to this carbon or this carbon atom, you will get the same product. Clear this point? So you take any symmetrical alkene and attach and add HBr or HCl or HI. So no need of any rules. Wherever it, for example, this is the ethylene, no, ethene. So symmetrical alkene I am telling you. We'll take another example to explain this. Okay. So is it clear? So let us take the second one. CH double bond CH CH3. But2ene I have taken and plus HBr. Now I have asked you. So here it is a symmetrical alkene or an unsymmetrical alkene. So here you check that one here, carbon, carbon. What are the attached groups? CH3, hydrogen, HCH3. Symmetrical alkene. So, if you shift pi electrons to this side or this side, you will get the same product. After the class, you can write and you can check also. Okay. So, what is the product you will get? So, I'll tell you the simple way of writing product. So, here you replace for this one. You replace if it is a symmetrical alkene. How to write the product? You replace, you just remove this double bond and write the product first. So here it is CH, CH, CH3, CH3. So what you are adding? H and Br you are adding, no? To H and Br will be added to these two carbons only, no? So you have removed a pi bond and the pi bond is between these two carbon atoms, no? So these two carbon atoms you add hydrogen to one carbon atom, this will become CH2 and this will become Br. Or you attach hydrogen to this one or Br to this one, this will be your product. That's it. What I told you, just remove this pi bond, H plus Br minus. So no need to write all that. So you add where here you have removed pi bond between the two carbon atoms. So here the pi bond is between the two carbon atoms. To that two carbon atoms you add hydrogen to one carbon, Br to another carbon. That's it. Okay. This is in the case of a symmetrical alkene. This is in the case of symmetrical alkene. Now I'll explain the Markovnikov's rule. Now here, what is the necessity of Markovnikov's rule? Now, clear till now? This is addition of HBr to symmetrical alkene. You got, I think you got one clear idea what is a symmetrical alkene is. Okay. Now, you just take propene. Prop means 3 carbon atoms, no? In. So, double bond. So, to satisfy the valency of carbon, I am placing hydrogens. So, here is your. Now, add HBr to this alkene. HBr to this alkene. Is it a symmetrical alkene? No. Here, the double bond is between the two carbon atoms. This carbon is attached with 2 hydrogens. But this carbon is attached with this carbon 1 and 2. Here, first carbon is attached with hydrogen and CH3. And second carbon is attached with 2 hydrogens. So here, both sides of double bond are not equal. Such alkene we call as an unsymmetrical alkene. Now, where to shift the pi electron cloud? To this carbon or to this carbon? Now, here to solve this problem, Markovnikov's rule. Markovnikov's rule. What is Markovnikov's rule? Here HBr, how it will cleave? H plus Br minus. Now what is this Markovnikov's rule states? Here negative part of the addendum. Addendum means added atom. Negative part of the addendum. Negative part of the addendum. This is the statement of the Markovnikov's rule. Negative part of the addendum means added molecule or the added ion. Added to the carbon. Added to the carbon. Which is that carbon? Negative part of the addendum added to the carbon containing less number of hydrogens. This is Markovnikov's rule. Now your problem has solved, no? So here, where to shift the double bonds and all? So here, again that shortcut trick. Here, negative part will be added to the carbon containing less number of hydrogens. So Br, you replace this pi bond. Replace this pi bond. First try to write this product. Here you should add Br to this one. Means this carbon will get a this carbon should get a positive charge. First carbon means the shift of pi electron cloud to this one. So this will get, this first carbon will get a positive charge, second carbon will get a negative charge. You attach this one to this one and this one to this one. So you will get the product. This is the general way of writing the product. So by simply looking at this one and this one, okay, how to write the product? So here you just remove that pi bond and write the structure as it is. Here it is your CH3 C CH2 CH. So here negative, what is Markovnikov's rule? Negative part of the addendum added to the carbon containing less number of hydrogen. So Br and hydrogen to this one, or simply you can write CH3 CH Br CH3. Okay. Another product also will form, means here reverse of this one. Here Br will be, in organic chemistry for every reaction we'll get two products, but majority, here this product we call as major product, and here if this is attached to this one, Br is attached to this one, we'll get this, we consider as a minor product. If somewhere in your textbooks or in your materials, if you are given like this, don't worry, this is the major product and it is the minor product. Okay, so this is Markovnikov's rule. I'll repeat once again, what is Markovnikov's rule? Here negative part of the addendum added to the carbon containing less number of hydrogens. That's it. Okay, this is one of the important topic for your board exams and for your competitive exams also. For now we are discussing the questions of the topics only for the board exam. Okay, this is Markovnikov's rule. I'll explain this Markovnikov's rule by taking few examples. Okay, now write the products for this one. HBr. So here all these are unsymmetrical alkenes if you observe. So here just follow Markovnikov's rule. HBr will cleave into H plus and Br minus. How to write the product I told you. You follow the mechanism or you directly write the product. First remove this pi bond and write CH2. Here is your CH3. Now here negative part of the addendum added to the carbon containing double bond. So here you have removed the double bond between these two carbon atoms now. So you place these two between that carbons only. Okay. So Br will be added to this carbon, because according to Markovnikov's rule, negative part will be added to the carbon containing less number of hydrogens. So Br and hydrogen will be added to this one. So CH3, you can write this one as CH3. That's it. So write the product for this one. Here you remove that one double bond, pi bond. This is your CH3, CH2 hydrogen. Negative part will be added to the carbon containing less number of hydrogens. So Br will be added here. This is the second one. Now write the third one as a homework. So here this Br will be added to the one, this one. Okay, this is about Markovnikov's rule, and here tomorrow I'll discuss what is anti-Markovnikov's rule. Okay, till then, bye.